Hello. This video will discuss some of the advanced features of KmPlot. Let's go ahead and open KmPlot by going to Education and KmPlot. I'm going to assume that you have watched the first part of this video, the basic KmPlot capabilities. What we're going to explore mainly today are some of the different kinds of equations that KmPlot can give to you. This is really one of the features that makes it much more powerful than the Leibniz graph plotter. You may have noticed in the basic video that every time we chose Create, I chose the Cartesian plot. So what we're going to do now is discover some things about these other types of plots. And I want to start with the implicit plot. So we're going to click Implicit. Now what implicit allows us to do is to write an equation in terms of both x and y. And the most basic example I want to show you is the equation for a circle. So we're going to type in the equation for a circle with a radius of 5. And that equation is x squared plus y squared equals 25. So when we do that, we get the equation for a circle. So this is a nice way to show students different things in algebra and trig when you try to describe the equation in terms of both x and y. Let me show you another example. Again, this is also helpful in geometry. We're going to type in the equation for an ellipse. So we're going to type x squared over 9 plus y squared over 16 equals 1. And we can see that now we have an equation for an ellipse. So again, to do that, we do Create and implicit plot. And so I'm going to put another one on here, another ellipse, and we're going to make that one a little bit different size here. Now I'm going to delete those to clear up our screen before I show you the next capability. So to do that, I click on the equation and I click Delete. The next thing we're going to look at are plotting in the polar coordinate system. And to do that, we do Create Polar Plot. So this will plot what we want, but in terms of polar coordinates. So let me choose a very simple example of r equals 3. Now in a polar plot, what we have to specify is the range of angles over which we're going to graph this function. And that is shown down here under plot range. So it's going to plot from 0 to 2 pi radians. So let me hit enter, and it draws a circle with a radius of 3. Now if we want to show only a half a circle, we can change the plot range to go from 0 to, for example, pi radians, and that just shows half of the circle. So I've drawn the very simplest function here of r is equal to a constant. Suppose I want to have a more complicated formula here where I have a function in terms of the angle. So in that case, I do need to use the functional notation. So I'm going to change this to r and a bracket, and I need to put in a variable for the angle. Now I can use x, but I would suggest that you not use x because it makes students think of the Cartesian coordinate system. So choose some other variable name. I'm going to use a to let that stand for angle, and I'm going to say let it equal to a. And I get a spiral when I do that. And let me try another one where I do, for example, the cosine of a, and that draws a unit circle. So again, to create a polar plot, we do Create Polar Plot, and then we type in our function. And I would suggest again starting it with starting it with R and using another variable, something different than x, for the angle, and then whatever your function is that you want. And remember, on polar plots you can select the plot range for the angle A, and it will start automatically from 0 to 2 pi, but you can change that to whatever you want. So again, let's change it back to pi, and in this case it doesn't make any difference with what I've plotted, since both of those will look the same from 0 to pi and from 0 to 2 pi. So that's the polar plots. That's a very nice capability to teach students how to work in the polar coordinate system. Now the last type of plot I want to cover is something called a parametric plot. So I'm going to go ahead and delete each of these now, my polar equations, by clicking on them and deleting. And now we're going to create a parametric plot, and that's the second one on the list. Now what the parametric plot allows you to do is to define both x and y in terms of some other parameter, in this case t. So let me show a simple example here. I'm going to define x as the sine of t, and I'm going to define y as the cosine of t. And when I plot that, it will draw a unit circle. And parametric plots are just like polar plots in that you specify the plot range down here. So it will automatically start from 0 and go from 2 pi for the value of t, but we can change that. So for example, we can just go from 0 to pi and we will get something that looks like that. Or we could go from, for example, minus pi, and to do minus pi I can click on this and choose pi as my constant and add a minus sign in front of that and hit enter. So again, parametric plots and polar plots are similar in that I can specify a plot range. In polar plots it's the angle, and then for parametric it's the value of my parameter here, t. So we've discussed the implicit plots, polar plots, and parametric plots. Now I want to talk about one other capability that we have, which is defining another independent parameter that we can change easily to show students how equations can vary. So let me go ahead. Let's start by creating a basic Cartesian equation. And I'm going to start with a basic function of x squared, but suppose I want to show my students the effect of multiplying a constant times this function of x squared. What I'm going to do is I'm going to add a constant k in front of this equation, and when I do that I also have to add a k in my functional notation. And you'll notice if I do it correctly, both of those variables will be colored green. So I now have an equation in terms of some constant k. Now when I hit enter, it doesn't really show anything. What I have to do is tell the program what values of k I want to graph. Now there are two ways to do that. One of them is using the option down here called list. So I'm going to click list and it will ask me to edit my list. I click edit list, and now what I can do is I can enter different values of k. So I'm going to say, let's let k equal to 0, k equals 1, 2, 3, 4. And so how I enter these numbers is I simply put my mouse up here, I type in the number that I want, for example 5, and I hit enter. So that allows me then to specify these different values that I want k to have. And if I click OK, now what I see are several different graphs that show the different values of this function x squared multiplied by k. So if you'll remember, I had a value of k equals 0. And so that's the line right down here. If k equals 1, it's this graph. And let me just click on that, and you can see I still get my values and my roots just as before, and I can click to turn that off. And let me do something else, and I click Advanced and show the plot name. When I do that, it will show the different values for k that I've selected. Let me turn that off now. So again, I enter my function, I put in the parameter that I want to vary, k, and I need to make sure that I include it in my function. And I can choose a list where I specify the different values of k that I want to show and plot. So that's one way to do it. The other way we can do it is to use something called a slider, and that gives you a more animated view of how things change. So I'm going to unclick List, and I'm going to click Slider now. Now I'm going to go up to View, and I'm going to show sliders. So now it's showing the sliders, and I have selected my function to use slider number 1. So as I move slider number 1 here from a value of 0 to 5, that is actually varying the value of k. So when k is equal to 0, the minimum amount, of course I have a straight line, y equals 0, and then as I move my value here, I can see how it changes as k changes. I can change my minimum value, so suppose maybe I want to go from -5 to 5, and now I can vary it, and now I can see what happens when k becomes negative. So again, this is a way to show students how functions change dynamically. By moving this, I can show students the impact of multiplying my x squared times some constant value as that constant changes. Now one other nice feature with this capability is I can right-click near the function, so I move my crosshairs over to the function, I click once with my right mouse button, I can click Animate Plot. If I select that, I can actually do an animation where k is changing with time. So I can make k get larger, or I can make k get smaller. And just like before, I can change my highest and lowest values of k, and I can also change my step size. So I want it to go from k equals -5 to k equals 5 in steps of 1/2. And I click the right arrow, and k gradually increases up to 5, and now I can have it gradually decrease until it gets down to -5. And I can change the speed of the animation. I can have it go very quickly, or I can have it go more slowly if I want to be telling the students what's happening along the way here. So again, to do that, I just move my crosshair up to the graph, click once with my right mouse button, and choose Animate Plot to get my automatic animation. But I can do something very similar here with slider, where I click on slider, choose the slider number, and do show sliders. where I can change my slider here. I'm going to show one more example of this for you. Let's go ahead and delete the x squared function. What we're going to do is we're going to create a Cartesian plot, and the basic function I'm going to use here is cosine. But what I want to show to students is how this function changes as I multiply the cosine times a constant. So I'm going to add my constant here, the multiplicative constant, and remember when I do that I need to also add that to my function. And they're both green now, so that's good. So I go ahead and hit enter, and now I'm going to enter a list. So I click list and I click on edit list, and this is where I can add my values. So I want to add 0 and 1, 2, 3, 4, and 5. So now I have my k value ranging from 0 to 5. 0, 1, 2, 3, 4, 5. So I'm going to see different functions here with the values of k, where k is multiplied by my cosine of x. And I click OK, and this is what I see. So I have actually 6 functions here where k is 0, 1, 2, 3, 4, and 5. So I make sure that I put my constant in my equation, I include it in my function notation, and I can use my list and edit list to add those values, or I can use my slider. So I'll turn off the list and I'll put on my slider. And I'm going to use slider number 2. So I go up to View, Show Sliders, and I'm using slider number 2, and I want it to vary from 0 to a maximum value of 5. And I'll move it over here, and as I move my slider back and forth now, I can see what happens as I multiply my function by values from 0 to 5. And you can see over here the value of k as I'm moving my slider, and it goes from 5 all the way down to 0. And if I want to show students an animation of this, I can move my crosshair over here to near the function and right click once with my mouse and choose Animate Plot. And again, I'm going to choose from 0 to 5, and I'm going to make it slow and a step size of 1. So k is going to vary from 0 to 5 in steps of 1. And I can click Go. So now I can see as k goes from 0 to 5 up and then back down to 0. So again, that's a nice capability to show students how functions vary over time. The final thing I want to show you is a capability in KmPlot to show derivatives and integrals. Now that is not a common part of the curriculum, but at least you might want to know it's here. So I'm going to delete this function, and I'm going to come back and create again a very simple function, my x squared. Now to show a derivative, I can click the derivative tab here, and I can say show first derivative, and it will show the derivative. And in fact, I can also show the second derivative, and I can change the color here if I want. So I'll make my first derivative red and my second derivative purple. So that shows my derivatives, and I can also show the integral. So let me click on integral, and I can click once and show integral. And I'm going to change the color of that to orange. So it's a very, very easy way to visualize what's happening when you do derivatives and integrals of a function. Now we can also then just turn those off, and we get back to our function. So those are available again under the Derivative tab and the Integral tab down in the function area. Remember, you can save your files just by going up to File and Save As. And I would suggest that you can save it in your My Documents, but you can also save it in All Users Shared on the Reneal server so students can access that. So you can actually create a KmPlot file, put it in All Users Shared, and then have the students do different things with that file. And I do recommend creating your file ahead of time because KmPlot is very powerful, but it is easy to forget different capabilities. I hope you enjoy using KmPlot, and thank you for listening.